Okay, then today we're going to talk introduction to some of the items. Business and information systems. Covered this. We've covered decisions that are with the aging. We talked about how you can design using a top-down process, and how important that is for systems that can have, no failure. They can't have any failure, compared to a bottom-up, where we create some type of a prototype or a model, and then we keep improving upon that model. Okay, the real plus of this is it's nice to see a working model and then make improvements to it. Plus, it's typically less expensive than top-down. Not as long either, not as long to develop. Okay. In all these processes, whether it's top-down or bottom-up, we can use programming to develop code to solve a problem. Okay? We have developed software starting as far back as, the weaving loom, and that was able to weave fabric, and all the way up to in the 60s start developing software to do mostly mathematical type problems and all that. But now we have software, and just think of any time you hear the word, well, there's an app for that. We're developing software now all the time, and everybody should understand how to develop software. Plus, the development, just the exercise of developing an app, is good for our thought process and our learning process. There's a lot of pluses to that. You could agree or disagree, but when you have some situation that software might be able to solve the problem, the most important thing to start off with is that you understand the problem. Then you can get the program specifications, and a lot of times what that amounts to is what can we put in, what do we need to do to process that, and what do we want out. There are lots of ways to get those specifications. You can use a couple of those ways is flowcharting and pseudocode. They will help you design a solution to the program, but you got to have the specifications. You've got to know, understand the problem, and what things are available to put in order for you then to figure out what you're going to process, and what do they want out? What is the result? What is the problem that needs to be solved? Okay. And so when we design it, these are two key areas of design. Pseudocode is false code. It looks like code, but it's text. You list things in the order that they're going to be done. It's text to do that. Flowchart are symbols. You have a start, and maybe you have input. And then maybe you'll make a decision, go this way or this way, and they'll all connect together, and you'll follow the flow this way or follow the flow this way. And all of this is so us humans can understand. Can understand. All right. Let's move up ahead then to the actual code. We design software then using these methods and other methods to get a design. And then we actually write the code. We write the code in a programming language that we as humans understand. There are lots of different types of language. There are procedural languages, there are object-oriented languages. Some languages fit into both camps. But when you hear about people designing code and writing in a particular language, once you understand what you want to solve in a path to solving it, up here, once you have the design, it would lead to the most appropriate language to use to solve it. And so as humans write the code, and then this code is converted into something the machine uses. That's actually on the next slide. Then we test the code. During the whole process, we document, make sure people know what is what in the code, what it's about, and what different lines mean, documentation so it's clear if somebody else needs to read the code. And then software is similar, this whole process is similar to any life cycle. Okay, it's similar to any life cycle. Once you get it designed, there's this huge part of maintenance. And if you have ever used a computer and you needed to download and install updates, that's what this is all about. Software is so sophisticated, it's hard to create perfect code. Okay, no code is perfect. In fact, software is released with known flaws. They don't advertise them, but they know there's things they are solving all the time. So we get these updates, or you'll get an issue, a place will report a vulnerability where somebody could access the computer via the software. Well, then now we have a problem. We define exactly what it is. We design a solution, we code it, document it, and install it. So it's this continuous cycle. All right. The next step is to talk a little more specifically about some steps right in here. But that's in another presentation.